happens to be that this morning we started with a certain guy called Kris Buytaert. My name is... You can't hear me? Okay. Let's try to... Can you hear me now? No? Yeah, thank you. Of course not, I'm not saying anything. Is this better? Is this thing broken by design? Okay. If you don't hear me, just wave. So, what I was saying was, as it happened to be this morning, you guys were treated with a nice introduction on Drupal 7 by Kris Buytaert. My name is Kris Buytaert, and for the zillionth time, no, we're not related, as far as we know. I use this slide to shortly introduce myself. What's interesting for you guys is that I'm mainly involved in infrastructure work. I try to build infrastructure that can survive the 10th floor test. Who knows what the 10th floor test is? Nope. One guy. Okay, that's already good. We've been trying to mark this for a couple of years now. The 10th floor test is basically the idea that you can take any machine in your infrastructure, database, web server, desktop, whatever, throw it out on the 10th floor of a building and be able to, one, continue running without your users noticing, and two, be up and running in a high available environment within the next 10 minutes. So that's what I try to build. And of course we try to do that with Drupal also. I have to mention, I'm really a Drupal newbie. I've been using Drupal for, I guess, 9 months, a year, something like that. Because I was looking for a configuration management tool, and there was a little bit of social pressure to actually go for Drupal. High availability. Why does it matter? You don't want to be down. Downtime is expensive, especially if you have a boss breathing down your neck and you have customers who are actually trying to do something with your site. If you have an online site where you are having an e-commerce site, or you're doing things with customers and customers want to have your service. So you don't want to have your machines down. But what's on the figures about high availability? People talk about the 6 nines. Who do you think can afford 6 nines of uptime? Is there anybody in this room who can afford 6 nines of uptime? Oh, I was going to say. Google can afford it. You can afford if you have to scale out really much, but most of the companies or most of the organizations and most of the people around, well, they'll do it 4 nines or even 3 nines. And if it's just for your local blog, well, you don't really care. But the figure of the nines means you have to be able to determine how important the service is for you, and you have to look at how much time and money you want to invest in your high availability. There's a couple of simple rules. You have to prepare for failure. Eventually things will break. Your site will go down, your ISP will lose connectivity, your disk will your disk usage will grow to the maximum of your disk ×2. So you have to prepare for failure if you want to have an infrastructure that's up and running. The second rule is you have to keep it simple. Because what Alan Robertson says is complexity is the enemy of reliability. So whenever you try building an infrastructure that's highly available, you have to take down the number of components that can fail. So if you build one piece on top of another and glue some stuff together, you're probably not going to be aware that one of the small components is going to fail. So you need to keep stuff simple. Okay, so Drupal usually is deployed on MySQL. Who's not using MySQL on Drupal? Sometimes Postgres. There's a Postgres talk about high availability going on in the other room. I have to miss it. So we talk about the database that's used the most for Drupal, which is MySQL. Historically, I'm speaking about 3 or 4 years ago, when you wanted to go for a high availability solution on MySQL, you basically had only one solution, which was replication. Replication back then was master-slave. If you were writing into the slave, your master was broken. So you had to adapt your application so that only one part of the application, which was doing all the inserts, was writing on the master node, and your read queries were done on the other node. Now you could use more nodes to scale the read, but you had only one part where you could do the reading. And you could use things such as Linux Virtual Server to actually load balance the reading. More recently, and I'll go over a couple of these shortly and a couple of other ones more in depth, there are other alternatives. MySQL likes to tell you that DRBD, which is a great solution which I'm using all the time in production, will help you to make your database high available. It won't. It will keep your data high available, but as your database SQL daemon crashes, you still have to power on the other side, and you still have to go to all the checks if your databases are consistent again. So you will have downtime there. However, if you're only aware, if you're only caring about my data, and you have to have your data available in multiple places, DRBD is a good solution. DRBD, by the way, is distributed publicly with divides. It's open source Linux kernel tool that is written by the guys from Lindt in Austria. And what it basically does is you have one file system, and everything you write on it is being mirrored to the other side, to another node. And that node can be on the other side of the ocean. The second one is cluster. I think, you have to correct me, it was introduced in 4.1 something, which is about 2 or 3 years ago, 2.5 years before beta versions. Yeah, something like that. So cluster NDBD was an alternative that you could look into if you wanted high availability back then. More recent, we got multi-master replication. So I told you on the previous slide that you could only write in one node, read in another. Well, that changed. You have multi-master replication, but there were some issues with multi-master replications with indexing. If you had an ID and you inserted another one, they didn't keep up. They didn't keep up. So recently, I think 5 something, they fixed also that problem. And then even more recently, and I'm also going to show you a couple of slides about this, is MySQL proxy, which was introduced, I think, December last year. So that's really new stuff. The important thing when you talk about MySQL and clustering is when you look at the solutions around MySQL, MySQL cares about your data. How do you access the data you have to query from? Where is it stored? What MySQL does not care about is how you connect to the database. So there might be a perfectly highly available MySQL daemon listening on port 306, but you might not have network to that port. Or the rest of the system might be broken. Yes? Can I increase the volume? Can you increase the volume? I'll go on and increase the volume. So, you have still to figure out how to... Is that better? Okay, thank you. You still have to figure out... And now it's to... Yeah. Okay. So you still have to figure out how to actually pull the traffic, pull your queries to the machine that's running your MySQL. Okay, cluster. The reason I'm here is because I was chatting with Dries over some beers, I guess over some beers. Should have been. And he said, well, you're doing all this cluster stuff and it sounds pretty interesting, but is it actually interesting for Drupal? I said, I don't know, I haven't tried it, so let's test it, we'll see. And basically, these are my experience with it. So what is cluster? Geert, you can correct me if you want to. Cluster is basically a shared nothing database where multiple nodes have nothing in common, apart from the data that they contain in memory. There's no shared storage, there's no disks that are to be shared. It's a single point of failure that doesn't exist anymore. So benefits are that you don't need to buy extra expensive storage solutions. And you don't depend on other storage devices. So if you typically have a storage cluster or an Oracle environment, the price for a one-node cluster, a one-node machine, which costs you €4,000, and a two-node machine is not 2 times the price of one same machine, but you have to add about 30 or 40,000 euros of storage. You don't have that problem here. What cluster does is it is able to partition data over multiple nodes. So it can spread the contents of your database over multiple nodes, and then it can query from those data nodes in parallel. So if you have 4 gigabytes of data, you have 4 machines, you can actually put 1 gigabyte of data on each machine. It's a bit stupid because if one node fails, then you still only have 3/4 of your data. So you also need replication. And the replication makes, you have to have a number of replicas defined, which is typically 2 or more. Some people put 1, but still then if you lose 1 node, you have part of your data gone. Replication makes sure that your data is high available. It's guaranteeing that you have, at commit time, it's present in multiple nodes, and they have a mechanism where everything is controlled so that if one node goes down, the other one becomes active. So, if you only have 2 nodes, and you need to store 2 gigabytes of data, you actually need 2 gigabytes of data on each node. So you need 4 gigabytes of data in total. So start thinking about large databases and scaling. If you have a large database of 4 or 6 gigabytes, which is not even large, and you want to have that scale over 10 nodes, you need 60 gigabytes, plus some overhead for the operating system and the management. Which is a bit of a backdraft, but it's also an advantage. Memory is still expensive, but on the other hand, you gain performance. Memory is so much faster than disk. Everything is in memory, but don't worry, there's asynchronous disk write, so it's not like you pull the plugs and everything is gone. There's checkpointing on disks and you still have all the data. But it's really a limit to what you can store in your database. I'm going over a couple of components of cluster, which will then total to the total architecture of cluster. So there's a couple of management nodes, a couple of data storage nodes, the MySQL daemon. Ideally, you don't run them on the same machine, but if you want to, you can. The management node is basically in charge of the cluster configuration. You have 1 config file on each management node, identical config files, and the management node is being used for each node that starts. It connects to the management node, it asks what's my configuration, where are my data nodes, where should I, how many memories should I allocate, and the daemons will start. The management node can be used to start backups, monitoring, you can enable logging there, and well, from there you have an overview of what's happening in your cluster. The MySQL node is a standard MySQL daemon compiled with the NDBD cluster feature. Cluster is just one of the engines you can use. You can use other engines next to it. So you can say, I want this application, for example, for a website, my PHP sessions, I want them to be in cluster. But all the other stuff, I just want to have in another database. And I want to be able to decide on a table level, this table will be in cluster, this table will be in a MySQL, this table will be in a Falcon or whatever. So when you create a table, you add engine. I think it's already the old syntax, right?
This is correct.
This is correct, okay. I know syntax changed between versions somewhere. It was engine equals cluster or engine equals enable, whatever. And if you want, you can enable it by default in MySQL config file. Then there's the NDBD node, who is actually storing the data in memory. And it's responsible for handling replication, the partition, the failover. And it has to be a multitude of the number of replicas. Yes, here.
Just want to know, this replication has nothing to do with the normal MySQL.
No, exactly. So this is the replication in cluster, and you can replicate clusters in normal replications, but it's just the replication of the data in your cluster. Okay. By the way, if you have some really in-depth cluster questions, ask him or... So, to have an overview, this is actually what it looks like. There's one piece missing on the slide, which is, and which I'm not talking about since you guys are mostly involved in Drupal and PHP stuff. There's an API here which you can use to talk directly to the database nodes, but if I'm not mistaken, it's only for Java.
No, C++.
C++.
PHP, C++, there's a number of APIs.
There's a number of APIs, okay. So that changed from last time I checked. So you have a management client which connects to the management server. Management server talks with the storage nodes, and the different MySQL instances connect to the management server to get information on where they should have data. This part actually during runtime can disappear. However, if something happens here and this is gone, you don't know where to go in this. But you can stop this, start this, as long as nothing else happens, you have no problem. And then your applications connect to your MySQL servers. Let's have a look at the time. So, what are the limitations with this part? Mainly memory, and well, as soon as you start getting load, you need to be able to update all the data in your database over the network. So you might end up having to invest in high-speed interconnect networks. As of
It's more the latency that's worrying, not so much the bandwidth.
it's latency and bandwidth.
Yeah.
Yeah, I've got issues in certain clusters now with bandwidth. So, as of 5.16, because memory was one of the issues, certain tables didn't fit in memory. We'll come back to that later. There was a feature introduced that's called disk-based storage. If you're familiar with other databases like Oracle and stuff like that, you'll see that the way table spaces and log files are implemented are pretty much similar. However, there's still a but here. Only the fields that are not indexed are on disk. Because we're going on to fix that, but still. So if you would create a table, T1, A, B, C, D, E, F, oh no, no F, which fields do you think will be in memory and which do you think will be on disk? So either everybody's asleep or... So exactly. C, D, E will be on disk, and A and B, because there are indexes on them, will be in memory. Now, this actually is a pretty important slide, because we'll come back to the Drupal tables and see how they hacked. Okay, this is taken right from my MySQL website, so I'm not lying here. There's also some other limitations, slow joins, not supported features. So, depending on your application, you might have good luck or bad luck. Now, I could ask the Drupal community, are you using this? Are you using this? But, well, we just tried the site. What?
You don't use code.
You don't use it. I noticed that. I didn't have the idea to go look into the code. But okay, so you have your database, your application wants to talk to a database. How do you get your application, in this case your Drupal, to connect to the right instance or to the instance you want your database to connect to? My favorite one. So people are laughing, they know I hate DNS and I think everything's a fucking DNS problem, so DNS load balancing is not an option. You could advertise your routing using RibD, virtual routing protocol. You could use LVS to just load balance with Linux Virtual Server or Linux HA. There's a couple of documents out on the internet. I think there's an O'Reilly article on Linux HA using Cluster, so I'm not going to go into detail there as we only have limited time left. They have to close this room at 6, I guess, so we have to finish before 6.
What's your preference out of those four?
Depends on what you're using. If you have scaling out, if it's just 2 machines high available, Linux HA. If it's more machines, and you have to be able to pull connections, LVS. But still, I'm going to go back to, because there's still other alternatives coming up. So, my test cluster. 2 management nodes, 2 data nodes. Not really a lot of memory. I've got about 1.5 gigabyte of data memory, about 500 megs memory. This is the cluster setup in my lab where I did actually the Drupal test. So, what was the first thing I did? I created a regular Drupal installation. It created all the databases for me. I dumped the database, replaced all the InnoDB stuff with NDBD, and I restored them. And that worked. Of course, that worked. Next step was, well, will my Drupal site still work? It worked. Fun. So, I wanted to put on more load, and I asked Dries, well, do you have a really big, huge database for me? So it will start out with the devil model, because who knows the devil model here? Should be, okay, so I don't need to explain. You can create users, stuff like that. And I started out creating 1,000 users. Fine. 1,000 nodes. Fine. Works fine. Then I tried 1,000,000 users. Who knows what usually happens on the devil? create 1,000 or 1 million users.
Either out of memory or out of time.
Time. This might be a piece that was big enough that you basically run out of time. So it took a long time. The insert, I had my playlog on, so I was seeing how many users were actually being created. And then when your session times out, you see that there was a fair amount of data in the database, but it timed out and, well, felt slow. So I wanted to test more. And then I got the Drupal.org database from Gerhard, which was about 600 meg zipped, and now I've got all your passwords. No, too bad. He sanitized them out, so I don't have your passwords. Unzipped, the database is about 2.6 gigabytes. And let's have a look at what's actually in there and what the big tables were, because that was my next interest. I knew it was running on a light system, small database. I didn't expect anything else, but I wanted to know which tables were using a lot of disk space and a lot of memory. Does this look like something that's normal for a regular Drupal setup for you? So you got the table name, the number of rows here, the data. Node revisions, this is Drupal.org. This is a live site, so it's about half a gigabyte of node revisions with some 100 megabytes of indexes. So, next step, try to get one of the tables, node revisions, into cluster. The first thing you notice is that if you are dumping large amounts of data into cluster, first time you try it, it's going to fail. Because you have to make some changes, the config files, that your log files are rotating fast enough, that you don't wait too long between checkpoints, because you will run out of session memory. So, half a gigabyte, I had 1.6 gigabytes of memory available, and I couldn't get the original 480 megs of data plus 126 megabytes of index. I couldn't get that in my cluster. It was just too big. So, let's try with disk space. Let's try with table spaces on disk. This was better. Well, my screen. After inserting that table into disk, in memory I was only using about 14%, and index was even much less. Well, my data files were actually growing. There was usage on my disk. Okay, so far so good. Now, what happens here is if there's a tool called ndb describe, which will tell you, based on each table description, which parts are going to fit in memory, which parts are going to fit on disk. For the majority of fields in the node revision, well, lots of stuff is in memory, but the big ones, the title, timestamp, there's lots of stuff going in memory. There's not that much stuff going in disk. So, let's try another table. Search index. You guys already know what's going to happen. Really bad. I didn't get, everything would fit on disk, but I didn't have enough index memory in my cluster to actually fit stuff. Of course, you can add memory, you can create bigger databases, but I'm trying to show the limitations of how far you can go and how fast you reach that limit. So what does the search index table look like? Even if I try to put it on disk, there's one field here that's going to be stored on disk. That's float. I tried some other tables, but the general idea you get is this is the common table. Disk. The subject is on disk, okay. Host name, but you see that the biggest part of what you get is mostly this, for example. Wow, we got 2 integers that are going to fit on disk. I'll put the presentation information online. You can look after it afterwards. Basically, I took the 10 biggest tables and I went to look at them. This is actually one that's search data set. Once again, search data. Nothing is on disk, so you need to have enough memory to put that kind of thing in your memory. Access log is one difference. Here, actually, because there's no indexes on it, you can save lots of stuff on disk. Drupal.org, the node entry, comments, sticky, so that's still okay, but it's pretty good. So, cluster in Drupal. If you're a small site, think up to 200-300 megabytes or up to, well, the memory can afford, it works. But bear in mind that the stuff you have on disk, from what I've seen, about 4 times bigger you need in memory. There's tools online which you can use to calculate how much memory you actually need. This is approximately what I've seen with Drupal. So I would say cluster isn't really a fit for Drupal unless you have a small site. When would I use cluster? Because I think cluster is still a product that has some benefits. I would use it in environments where we have to do session handling. Small, volatile data that's being proxied out of the database after 5 minutes, 10 minutes, but it needs to be there, it needs to be live, it needs to be fast. Just put it in there, get it back out. Small data sets, but not with large data sets yet. I hope that the developments that are going on regarding disk-based storage, I see here nothing, so I hope that those will improve. What do you want to do with large data? Typically logs, archiving table was a bit of an example where it could be used. But we can use cluster as a front end and then query data from the table, get it out into an archive table, and then delete it again. So you can still use cluster there. But what else? This is not a MySQL tutorial, so I'm not going to go into all the details. You can start with partitioning your data yourself. You can start with placing certain parts of your data on other nodes yourself. You could use MySQL to do that. There's features to do it. Since multi-master replication is now supporting good indexing and is now a feature, I think you should probably look into multi-master replication. Or proxy. What's proxy? Who was in the 15-minute talk? Okay, so then I will have to explain. No, proxy is pretty new. It's what Jan called the man-in-the-middle tool, and basically lets you decide where you're going to connect to. If you already have an application, for example, that you want to have on a multi-master slave replication, you can use proxy to say, okay, all my insert and update queries go to this node, and all my read queries are going to go to another node. And you need to know a scripting language called Lua to get there. So I got this picture from a CME. I could use it to show how our proxy actually worked. So you have this client who thinks he's talking to a database node. Actually, it's not, because he's talking to this nice dolphin here, pulling plugs and deciding where he's actually going to route your traffic. So you send in a query, the dolphin sits there like it says, this is a query which is for user 54. Well, you don't know it yet, but we actually placed all the data of user 54 in database server number 54, so I'm going to send your data over to database number 54. You don't know it, but I do. Database replies, gets back, query to proxy, proxy places everything back to the client. This is stuff you can do. You can insert queries, you can filter, you can rewrite, and you can actually scale out rather than place a higher machine. And I think this is one of the things that will, it's still a young product, so there's still a lot of work to be done. But I think this is one of the tools that, apart from multi-master replication, is really interesting to look at if you're running a large-scale Drupal site. So you could split read and write actions. You can send specific queries to a specific node, user 58 to your table 58. And you can also use it to load balance. So when you were asking, do you want LVS, do you want Linux HA, you might want to choose MySQL proxy rather than LVS but I still need to figure out how to make MySQL proxy high available, how to get connections on MySQL proxy available. But still there I can use Linux HA. So it's going to be a mixture of both depending on. Okay, so I think we're going to finish before 6. Conclusions for today is, if you're building a high available Drupal site, if you're building a high available MySQL site, bear in mind that MySQL manages high availability of your data. So you'll probably end up having 2 different instances of 2 different clusters. One that's taking care of your data. The second one that's taking care of the connecting and the way how you connect to your data. If you're using cluster, if you've got a vast amount of memory and you've got a vast amount of money to buy that memory, you might get somewhere. But if you really not want to spend too much money on memory, Drupal and cluster, no, I don't think it's a good match. Multi-master with indexing fixed is back. I think Jesus has been, one of the features he listed on his wish list today was master-slave replication. We have Drupal support for that. I wouldn't waste time on that. I would just do this. And proxy definitely, well, you don't need to have master-slave and awareness in Drupal for that anymore, because proxy can fill that out for you. So that's a bit my conclusions on Drupal and MySQL availability. Well, you guys all read Planet's Drupal, so you know where to find me, because I'm also writing there. Yes?
I have a question on the proxy stuff. I can give you a use case. Yeah? For example, the query which gets all the comments for a node, which display below that, is what we call a pager query. Now I have patched Drupal.org to do master-slave replication, and we usually send this query to the slave because, I mean, it's just a read query, right? But this does not work if a user just created a new command and he then gets redirected to the node and gets shown all the comments again, because his node, his new command might not be at the slave at the time.
It might not use your code. It might not use your patch. Because you'll be patching stuff. So the new user,
yeah, no, the new user does not see his new command and is confused because the command got retrieved from the slave and the slave didn't have the information on it. So I had to pull some trick in order to allow this. So the question is, would MySQL proxy be possible and would it be able to do this, to anticipate this? No.
Well, you can query the slave if the information is there.
Yeah.
That should be possible.
Yeah, but the way the query works, it doesn't really know about it. The query just asks, give me all the commands for that node, and it doesn't know for which command it actually is looking at.
Because it could query the slave how much is behind, and then can choose which of the slaves has already caught up with the master and pick this one to execute the query.
What the question is that does the way the proxy can do that for you?
Yes.
If the proxy is aware of the update that's gone through, would it be aware of which slaves are in sync?
I'm pretty sure, yes.
Ooh, that's nice.
That would be awesome.
And Jan Kneschke should be able to tell you how.
Okay.
Do you have any production experience with MySQL proxy yet?
no, proxy not yet.
And anyone else? The open source project uses it for their download innovation. So is it in your opinion ready for prime time? Yeah. Jan could probably confirm this better since he's working on it, but we have several people using it in production. And they are so far,
I think they're happier with proxy than with cluster.
It's a different use case.
That's my
my first argument.
I think the nice part about proxies is that it's really transparent to the application, but to modify it in the way.
Any more questions?
From your experience as a creator for do you have any insight how we can change this?
I'm not sure if you want to change it for. You said. Well, let me repeat the question. From my experience, it looks like Drupal does not really fit the cluster. And is there any advice on how to change it? I don't think you have to change it. I just think that cluster is not a good fit, and there's other tools that are fits. And it's just the truth we have to live with that. It's not the right shoe, so why try to fix the foot in the shoe is good?
I just want to add that clusters specialized for quite some markets, for telecom more. So doing this altered table from one engine to cluster, it's never going to fit. Because you have to really build upon the cluster and make the application aware of it. You cannot just take something and put it in there. It might work, but usually it doesn't. We have had customers who moved something in and then complained about something, but that's the way it is. So you have to use cluster for what is best for you, like everything.
Which is what I was
Yeah.
trying to say, because otherwise you end up having all these people asking, well, I'm using cluster here and it's not really working.
Cluster is cool.
Yeah, you can still see
Yeah.
where it comes from. Cluster is a product that has been acquired by MySQL from another company, which was a spin-off from Ericsson. Cluster was there used in branch exchange systems for logging and doing, as you said, high volume but very small data sets. That's why they chose the design of using it as an in-memory database. And these are the purposes where MySQL cluster currently is mostly widely used and very successful there. Mostly Telegram.
And just to add on that, I hear a lot of time MySQL is used only for little websites. We are now powering some of the most biggest GSM networks in the world, so with cluster. So this is not a small thing. This is quite big, and it works very well when it's used correctly, and when it's like me, I'm supporting those customers. They are really testing a lot, and they develop on it. So it's really a specialized market.
I can confirm what Geert is saying, because I'm using cluster in a couple of satellite provisioning systems. So it's really working good, but you have to know what you're doing, and Drupal is not what you should do with it.
Yet.